The objective of this video is to acquire understanding of multiplying polynomials. Remember that a polynomial is an algebraic expression with more than one term. We're going to start by multiplying a monomial, let's take 2x, by a binomial. So we're going to multiply 2x by x plus 7. X plus 7 is a binomial because it contains two terms, x and 7. To do this, we're going to apply the distributive property, and so therefore we're going to take the factor 2x and multiply it by each of the terms in x plus 7. 2x times x becomes 2x squared, and 2x times 7 becomes 14x. So this is the application of the distributive property, which, as we'll see in a few minutes, can be used to multiply polynomials of any size and degree. I'm going to introduce now another model, and we're going to call it the area model, because we know that the area of a rectangle is the base times the height, so the product of its base and height, and we can use our two factors as the base and height of a rectangle. So we're going to label the height 2x and the base x plus 7, and we're going to divide the base into its two pieces, x and 7. Now we've created two rectangles, and we can find the area of each one and then add them together to get our total area. So the area of this first one is 2x times x, which is 2x squared, and the area of the second one is 2x times 7, or 14x. Now combining the two areas, we have 2x squared plus 14x, which is another way to find the product of 2x and x plus 7. Now obviously the distributive property method is probably a little bit faster than the area model, but the area model gives us a visual picture of understanding it, and its usefulness will be in the next topic that we'll cover, which is factoring polynomials. The area model becomes very useful in factoring polynomials. Let's multiply binomials. So let's multiply the binomial x plus 4 times 2x plus 5. And first we're going to do this using the distributive property, and therefore we have to take each term in our first factor and distribute it to each term in the second factor. And so we could write this out as x times 2x plus 5 plus 4 times 2x plus 5. So what we have done is we've taken the x and distributed it to both of the terms in the second factor, and then the 4 and distributed it to both of the terms in the second factor. And so now we have simplified our multiplication of binomials into the multiplication of a monomial by a binomial. And so we'll go through the process. X times 2x becomes 2x squared. X times 5 becomes 5x. 4 times 2x is 8x. And 4 times 5 is 20. And when we combine like terms, we see that 5x and 8x are like terms. They will combine to make 13x. And so the product of our two binomials is the trinomial 2x squared plus 13x plus 20. Now bear in mind that in the next video we are going to be starting with a trinomial, and we're going to want to break it down into its binomial factors. Let's use the area model now to find the product of the two binomials x plus 4 and 2x plus 5. Let's label the base of our rectangle as 2x plus 5 and its height as x plus 4. And now we're going to divide our larger rectangle into 4 smaller rectangles. So we're going to break up the base into its length of 2x for this part and 5 for this part. So this will be 2x and this is 5. And we're going to do the same thing with the height. So we're going to call this part x and this part 4. And so as you see, the original rectangle is still the same rectangle, and so we can calculate its area by calculating the area of each of the 4 smaller rectangles. So let's just label the remaining sides. Since this is x, so is this, and this is 4, so is this. This is 2x, and this piece is 5. And so the area of this first rectangle is 2x squared, 2x times x. This one is 4 times 2x, or 8x. This small one here is 4 times 5, which is 20. And finally, 5x. And so to get the area of the large rectangle, which actually is the product of our two binomials that we started with, because that's what we chose for the sides of our rectangle, we combine like terms and we add the areas that we calculated. And so we end up with 2x squared plus 5x plus 8x plus 20. Combining like terms, we have 2x squared plus 13x plus 20, which is the same result that we got using the distributive property. Let's try one more example of multiplying binomials, and this time we'll include negative terms. So let's multiply x minus 4 times 3x plus 7. So using our distributive property, we're first going to distribute the x to each of the terms in our second factor. And so x times 3x becomes 3x squared, and x times positive 7 becomes 7x. And then we're going to distribute, and we're going to use this as a negative 4. We can think of it as a subtraction symbol, but remember that subtraction is just adding the opposite, and so we're going to look at this as a negative 4. A negative 4 times 3x gives us negative 12x, and a negative 4 times positive 7 gives us negative 28. And again, we combine like terms, which yields 3x squared. 7x minus 12x gives us a negative 5x minus 28. And so the product of x minus 4 and 3x plus 7 is the trinomial 3x squared minus 5x minus 28. We'll do one final example to show that we can multiply polynomials of any size using this distributive property method. We can also use the area model. Let's multiply x plus 2 times x squared minus 3x minus 1. So it just means distributing again, x times x squared, that gives us x to the third power, and then we multiply x times negative 3x, which gives us negative 3x squared, and finally x times negative 1, which gives us negative x. And now when I multiply the 2 by each of the terms in our second factor, I'm going to put the product underneath the like term that I already have to make it easier to combine them. So 2 times x squared is 2x squared, and then 2 times negative 3x is negative 6x. Whoops, wrong color. Negative 6x. And finally 2 times negative 1 is negative 2. And so now we'll combine like terms. And so the x cubed is by itself. Negative 3x squared with a positive 2x squared becomes negative 1x squared. Negative 1x and negative 6x become negative 7x. And then the minus 2. And so this time when we multiplied a binomial by a trinomial, we ended up with a polynomial of 4 terms.